a way to help maybe not bog down the Wi-Fi a little bit. So I'm just gonna, when I'm teaching, I'll take myself off, but at the beginning and end of every class, I'll be on camera so I can talk to you and you can actually see who I am. All right, so the recording's up and going. Just gonna share my screen. It might take a minute here. Okay, so you should be able to see what I see. I'm just gonna wait for the little pop-up window on the bottom right, so it might be taking a minute to load on your computer. Okay, we should be good. So just to let everyone know, those of you that are new and those of you that are not new, just a reminder, because there's a lot of things you have to know for each of your classes, especially if you're taking more than just the 10C here with us. Every instructor runs their class a little bit differently. You just have to get used to the way each course is set up. So it's going to take a little bit of time. So if you get into Microsoft Teams and you pop into our class here, it usually brings you right to the general page. And this page won't be used for much. I have a welcome message. You probably won't see much else on here. If you happen to send me a message in here, I'll probably respond. But that'll be about it that's in the general page. The most important ones are going to be what's called our week pages. So each week I'll make a new page and our recordings will come out of those, or we'll have our meetings in those corresponding weeks. So right now you need to find week 1. And thank you, Seda, for letting me know that in some cases it's saying 3 hidden channels. So if you just highlight this or put your mouse over top of it, you'll have an arrow here. You just click on it and you can find what room you need here. So week 1 might be pop up down here for you. So you click on week 1 for today and tomorrow. And once you get into the room, you'll see this here if the class is going, and you just hit the join button to jump in. Next week, starting Monday, I'll send out a new request or a new invite to you for week 2, and I'll open a new page here called week 2. And that's where you'll go to find our classes for next week. I'm just looking at Jonathan's question here. So he just popped up, does prime factorization work for finding the GCF of 2 single numbers, 1 single number, and 1 double, or just 2 double digits? Jonathan, it should work for every number. So every combination of numbers. So if you have 2 2-digit numbers or 1-digit number and a 2-digit number, prime factorization will work for anything. Okay, and I had a question earlier today about finding LCM again. So what I'm going to do before we actually start today's lesson, which is lesson 3, I'm going to throw up a question from the workbook. I actually picked a really tough one. We're going to look at question 4B on page 12. And we'll look at that in a minute. And I'm going to show you how to find the GCF and the LCM of those combination of numbers. So we'll do a bit of a quick review with that. And then we'll move on to our topic for today, which is called rational and irrational numbers. So yes, that process, Jonathan, prime factorization should work for any combination of numbers. No, that's fine. The questions are good. Yes, so whatever is common in the list, so if both lists happen to have, so question 1A, for example, what you were just pointing out, where you're looking for the greatest common factor of 14 and 21, the largest common number to both lists will be 7. So that would be the answer, just 1, 7. That's for GCF. LCM is a little bit different. Okay, and then hopefully when we do that question from the workbook in a few minutes here, because it's a really tough one with big numbers, that'll hopefully clear up some of the questions. And then, of course, if it's still not making sense, we'll have a question period there too. So we want to make sure that you have a good grasp of that before we move on to the new stuff. Okay, so that's the Microsoft Teams there. So week 1, and then again, there'll be a week 2 in there. You're welcome. Okay, and then for the recordings, depending on which week we are in. So currently we're in week 1. So again, you would go to that page if ever you wanted to watch the recordings. So if you're new to the class and you weren't in another section just transferring, and you just jumped in, so you've missed a couple, you've missed lesson, I guess, 1 and 2 out of the workbook. You can find those recordings in this top tab here, or the top menu bar. So here's Tuesday, January 12th. And if you just hold your mouse over it again, it will tell you Tuesday, January 12th recording. So that's from Tuesday. And yesterday's will be in this list where it says 1 more. So once there gets to be too many things up top here, what Microsoft Teams does is it makes a list like this. So you just have to click on that down arrow to get the drop down. And there's Wednesday. So that's yesterday's recording right there. So if you need to catch up with us, you can just watch those 2 recordings. They're about an hour and a half each, so make sure you have a good chunk of time to watch them, but you can always start it and stop it if you have something to do and come back to it after. But those are there for you. And if you want to tune into the orientation on Monday, where I went through all of D2L and Microsoft Teams and how we're going to use both programs, that would be if you go into the 2 hidden channels here, highlight that, and go to the Welcome and Orientation class. So if we click on that, there's a bunch of us just chatting back and forth, but where you'd find the recording is up top here. So it says posts, files, and again, it's telling me 2 more. So I would just use the drop down menu and find the actual recording there, and you can watch that. So that's where you'll find all the recordings. I'll always put them in the top bars here. Okay, and then I'm just going to jump to D2L really quick to give you a couple updates. So I just posted this morning. You may or may not have seen it. I'm not sure I mentioned, I think it was my other class. I didn't mention to you guys what my office hours would be. So just so you know, I'm not working full time, like a full 8-hour day with Bow Valley College. I'm working about half days. So my time's a little bit tight, but I do have an hour each day where I'll be able to answer any questions you might have. So you can just send me an email or chat. And you can actually send me an email message in D2L here or a chat message at any time during the day. Just know I won't be able to get back to you until I'm actually online working. So it'll usually be between 10 and 11 in the morning, Monday through Thursday. And I have a little bit more time on Fridays. So on Fridays, it'll be from 10 till 12:30 that I'll be available outside of class time. Okay, so that's just up there for you just to let you know when I'll be online working. And we've also got our first assessment again, but this assessment's not for marks. This is just like basically a practice test, just to give you an idea of what questions may or may not look like on quizzes, how to use the quiz feature, that kind of thing. So you're still expected to do it, but it just won't be marked. It will open up tomorrow at 8 in the morning, and it will be available to you until 11:59 p.m. tomorrow evening. So you have the entire day to find some time within there to do this numbers self-assessment quiz. And it's just based on the first 2 lessons that we've done here, and there may be a question from today's lesson. May or may not be, but it's not for marks, so it's just, again, just to get you used to the process. It is open from 8 to 11:59, but that doesn't mean you can start the quiz at 8 and do a question here and then close it and come back to it later and do another question. All of your quizzes and unit tests will be timed. So each quiz you will be writing online you'll have a time allotment of 90 minutes or an hour and a half, which for tomorrow's quiz is definitely more than enough time. It should be fairly quick for you. Most of it's multiple choice, or you'll have to just input one number as your answer. It shouldn't take you too long, but just to get in the habit of it, make sure before you start the quiz that you have a chunk of time. Give yourself an hour and a half, because as soon as you click Start Quiz, it starts timing you. So you have to complete it within 90 minutes once you've started it. Once you've completed the quiz and put all your answers in, you just click Submit Quiz, and that's it for this one. So we don't have to get into using Adobe Scan yet. That'll be for next week's quiz when we actually start submitting things for grades. So your very first graded assessment will be next Friday, okay? And I will go in more detail about Adobe Scan and how you will use that for next Friday, but for tomorrow you don't have to worry about using that at all. You're literally going to go into the quiz, open it, or click Start Quiz, put all your answers in there. Once you're done, click Submit Quiz, and that's it. That's all you need to do. I will put a news item in here, either later today or really early tomorrow morning, and I'll provide the link to the quiz. So you can basically click on it, it will take you right to the page. You click Start Quiz, and away you go. Another way you'll be able to always find your assessments is in the Assessments menu up top here. Click the drop down and go right to Quizzes. You won't be able to find it yet because the quiz isn't available to you. But it will be called Numbers Self-Assessment. That'll pop up tomorrow as at 8 a.m. You'll be able to see this when you go into this menu. And just click on it. And your page won't look like this. It'll look different. It'll just have some instructions. It will tell you how much time you have. And at the bottom, it will say Start Quiz. And that's literally what you click on. And it will open for you and your questions will be right there. And do not forget that when you're done that you actually click Submit Quiz. That's the only way that will close down for you and you'll have your answers inputted and I'll be able to take a look at them. Okay, any questions on that? I'm just going to pop back to our meeting screen here. There we go. Andrew, yes, we do have meetings on the day we do assessments. So we do have classes every day, Monday through Friday from 2 till 3:30. So you can choose most of your assessments, unless if we have to make a few adjustments here and there. But if you look at the calendar in D2L, everything's slotted in right now for Fridays. So you basically, for the entire term, have an assessment, whether it's a quiz, an assignment, a project, or a test. You'll have something due every Friday. So with assignments and projects, you'll obviously have more time to complete it. So you'll have a couple days in there and then you can submit it by the end of the day on Friday. But quizzes and tests, you only have a certain amount of time and it has to be done on Friday. And we still will have classes that day, so you'll just have to work around our class time if that works. Okay, any other questions? Yes, Seda.
Yeah, we have my favorite things and tomorrow assignment for quiz, all right? Only
That's
two.
right.
So far only two, huh?
That's right. So far it's only 2.
Okay, thank you.
Yeah, you're welcome. And that my favorite thing, good question. Some people might not remember about that, but if you go into content, okay, and then you've worked through where it says weekly guides, week 1 here. So again, you won't be able to see all of this yet. I'm just opening up things week to week for you, so it's not overwhelming. But in the course orientation there, this is just a little background of me, about me a little bit. There's the workbooks you need to have. So that's the workbook and the student solution manual, a link to the bookstore. One of the calculators you should have, it might not look exactly like this, just as long as it says TI 83 or 84 on the top of some kind, that's exactly what you need. And then just a little tour of D2L here, telling you what the important parts are. There's a startup survey. That's also in the quiz feature, so that's again getting used to using that quiz. This is a tutorial on how to download and use the Adobe Scan app, which is what we'll be using starting next Friday to submit your work. And this is a video that shows you how to submit your work once you use Adobe Scan. And then this was just for practice, so just to get used to using the app. So once you've downloaded it and watched the tutorials, we just asked you to draw a picture of your favorite thing, just for something to have on paper to take a picture of. And then you use your Adobe Scan app to take a picture of it, save it as a PDF, and then you can go into right here, my favorite thing, it takes you right to the Dropbox. And I've already got, oh, Sadie, you already submitted yours. I've already got a lot of ones in here. Perfect. So most of you guys have done it. But there'll be a spot in here where it says you can upload a file, and you can just upload your picture there, and then you're done. And as long as it works and everything's in there, that's how you're going to submit all of your assessments.
Thank you.
Yeah.
I have a question about that. My favorite thing, is it going to be used by everyone, even if you're going to use a printer at home?
Do you mean you need to print it?
No, I'm asking if it is about the Adobe app that some people are going to use to submit the assignment.
Yeah.
Or is everybody going to use the Adobe?
Oh, do you need? Oh, so do you mean you need to use the app all the time to submit?
Yeah.
Yes. Yeah. So we ask you to do that because the Adobe Scan app, or you could use what's called Cam Scanner. A lot of students that have been with us for a while have used that before, so they liked the Cam Scanner. Okay. They both do the same thing. So it's your choice. We just kind of chose Adobe Scan, and that's why we just kind of just pushed it in our classes. So you'll see that pop up and with tutorials. But if you prefer using Cam Scanner, you can. You just need some type of app that will scan your work for you. So yeah, there are printers. Like if you have a printer at home where you want to do all your work on paper, because that's what you need to do. And if you can scan your work using your printer, you can also do that, just as long as you have some way of scanning it and saving it as a PDF.
Oh, okay, yeah.
Yeah.
Because I have a printer that I can do my work, and I thought if I have that, then I should not do the Adobe thing.
Yeah, for sure. If you've got a printer that can scan your work after you've completed it, and then you could submit it as a PDF file, that's perfect.
Oh, okay.
Yep, absolutely.
All right, thank you.
You're welcome. Yeah, you just need something that you can take a picture of your work or scan, something that's able to scan it, so you can submit it as an actual PDF file. Okay. All right, any other questions? Excellent. Okay, let's get started. So let me jump into my Word document I have for us for today. There we go. Okay, so I have these crossed out just because we've covered lesson 1, we've covered lesson 2, so our focus today is going to be lesson 3. Now, before we get into rational and irrational numbers, let's take a look at, this is the question I was talking about from the workbook. So I'll write down the page and the number if you want to refer to that, if you have your book with you. And if you're still waiting on your book, you can, there's the PDF files that are in D2L, so you won't fall behind. You can download them to your computer, you can print them. But the first unit, there's PDFs for every lesson up there, so you don't have to wait for your workbook to get there. Okay, so this is on page 12, and this is question number 4B. Okay, so if you look in the workbook at that question, if you've done this question, it only asks you to find the greatest common factor of these 4 numbers. So I added, let's find both, the greatest common factor and the LCM. They both require us to do prime factorization, but then once we have the prime factorization, determining the GCF and LCM, there's a difference in the process of both. So I think for the most part, students tend to have an easier time finding GCF. LCM seems a little bit more unnatural, I guess. It's a little bit more challenging to get that process down. So we'll take a look at both of these. So to prime factorize, you can either use the factor tree method or you can use the division table method. So we talked about this yesterday, everyone that was in class, and I said my favorite used to be the prime factorization tree, but as I'm using the division table more and more, I kind of lean towards more this one now, just because it keeps things a little bit more organized. The trees can get a little bit messy, but as long as you're on top of it and making sure you're circling each prime factor. Once you get one, then you should be fine. Okay, so if we prime factor 128, the only thing with the division table is that when you are looking for a number to divide out of 128, it has to be a prime number. So anytime a number's even, I've been telling you guys this, I always just kind of default to 2 rather than having to play around with finding other prime numbers. We know 2 is prime, we know 2 can be divided out of any even number. So I put the 2 outside there and I do 128 divided by 2, which gives me 64. Again, it's even, so I can do 2 again. I just want to give you a reminder too. A lot of times when we see 64, what's natural for us is to do, oh, we can take out 8. But you got to remind yourself, no, I can't, because that's not a prime number. 8's not prime. Got to use a prime number on the outside here. So let's do 2. And if I half 64, that gives me 32, which is prime again, or sorry, even again. So I'm going to use 2 again. 16, which is even, so let's use 2 again. 8, 2 again, 4, 2 again, and I get 2. So 128 ends up being 1, 2, 3, 4, 5, 6, 7 2s. So that's the prime factorization. 984, again, it's an even number. So I'm just going to go with 2 to save myself some time. So when I divide by 2, I get 492. Divide by 2 again, because that's even. We'll get 246. Still even, so let's use 2 again. 123. Okay, finally we don't have an even number, so I can't use 2 for 123. So you can use the division or the divisibility rules if you'd like to try and find another prime number that we can take out of 123. The first inclination would be to use a 3, right, because it ends in a 3. But if I try to add my digits together, because that's the rule to figure out if a number is divisible by 3, you add the individual digits together. So 1 plus 2 is 3, plus 3 is 6. So because 6 is divisible by 3, this number should also be divisible by 3. Okay, and if you don't like the divisibility rules and having to remember those, you can just try prime numbers. Just do 123, you can just try, divided by 3. If it works, great. If not, the next prime number would be 5. If that works, great. If not, the next prime number would be 7. So you just keep trying numbers to divide out of there. So I get to 41, and 41 is a prime number. So I'm going to stop there. So moving on to 1496, it's even, so let's go with 2. So if I do 1496 and I half it, or divide it by 2, we get 748, which is also even. So I'm going to divide by 2 again. We get 374. Divide by 2 again because it's even. And then we get 187. Now it's not even, so 2 won't work. You can try just plugging in 187 divided by 3, or you can add the digits together. 8 and 7 is 15, plus 1 is 16, and I can't do 16 divided by 3, so that means this number will not be able to be divided by 3. Our next prime number is 5, but a number has to end in a 5 or 0 to be able to divide out 5, so that won't work. We could try 7. That's the next prime number, and that doesn't work. 11 would be the next prime number, so 187 divided by 11. That one actually does work. It gives me 17. And 17 is prime, so we can stop there. And our last number is the biggest one, so 3080, it's even, and it also ends in a 0. So I'm going to actually go with the 5 instead. So again, anything that ends in a 0 or 5, we can always divide 5 from it. So 3080 divided by 5 gives me 616. Now it's even, so I'm going to go with 2 again. So 616 divided by 2, we get 308, which is even. So let's divide by 2. We get 154, which is also even, so divide by 2. And we get 77. And I can either use a 7 or an 11 with 77. So let's go with 7. And then my answer is going to be the opposite number. So I get 11. And 11's prime, so I stop there. Okay, so that was quite a bit of work, but that's just the prime factorizations only. So now what I can do is I can list my prime factorizations, and what that is I literally just take all of my prime numbers, which is on the outside and the bottom, and I say, okay, my original number 128 is equal to all of those prime numbers multiplied together. So I had 7 2's. One more. Okay, and you can double check if you don't believe me, but if you multiply 7 2's together, you should get 128. And 984, we've got 3 2's, 1 3, and a 41. So 2 times itself 3 times a 3 times a 41. And then 1496 has 3 2's, 111, and 117. And our last one, usually when we're writing out prime factorizations, you always want to start with the smallest number and work your way towards the biggest number just to keep them nice and ordered. So I had a 5 first, but my 2's are the smaller numbers. So there's 3 2's, 1 5, 1 7, and 111. Okay, so I would suggest, especially when you're doing a test, but also for yourself on your assignments, just quickly double check these that we didn't miss anything in here. So just do what I said in the beginning with 128. Multiply all those two together and make sure it does equal 128. Multiply the 3 2's, the 3 and the 41 together, make sure it equals 984. Make sure these numbers multiplied together give you 1496, and make sure these give you 3080. Because it's awful when you do all the work right, and as you're writing out your prime factorization, maybe you'll miss something. And then, of course, your answer is going to be wrong, even though you've done the prime factorization right. So it gets a little bit frustrating. So where you can, always double check everything. Okay, now for the GCF, GCF is easier because we're literally taking each number that's common to all 4 lists here. So what I mean by that is when I look at my first number 128.2, it exists in 984, it exists in 1496, and it exists in 3080. So that's one of my numbers that's going to make up the GCF. Each list also has a second 2. So that second 2 makes up the list. Each number also has a third 2. So another common 2. Now I've got another 2 in 128, but if I look through my list, there's no 2's in the other ones, so I can't use that 2. I can't use any of the rest of these 2's. And because there's nothing else common in all 3 lists, even though there's 2 11's in 2 lists, the 11 has to exist everywhere. So there's no 11 everywhere, 5 doesn't exist everywhere, neither does 41, 17, or 7. So that's literally it. So for your GCF, you're taking those 3 common pieces that they all have, and you multiply it together. So what that means is the greatest number that can be factored out of all 4 of those numbers is 8. Okay, now the LCM, this I think is the more challenging one I was saying. But once you get the process down, it's not too bad. So with the LCM, always start with the full prime factorization statement of any of the numbers. So I usually just by default, to keep my process always the same, I always just start with the first one I've listed. So all 7 of these 2's is going to be part of the LCM. So it doesn't matter if I start with all the 7 2's, I could choose to start with everything from 984, or I could start with everything here or everything here. You're going to get the same answer in the end. So what I'm going to do is I'm going to cross off everything I've used so far. So I've used all 7 of these 2's, so they're going to go. And because I've used 7 2's, that means I've taken care of the 3 that exists in the other ones. Right? So these 2's basically go together. I've used those. That 2 goes together, and that 2 goes together. Now, what's left over, we have to add into our list here. So anything that's left over that wasn't used. Okay, so from our second list, we didn't use the 3. So we're going to add the 3, and now it's been used. We didn't use the 41, so now that's been used. Okay, and then our next list, we didn't use the 11. So when we use it, I take it away from where it exists everywhere. So that's been used. And then I still have a 17. I still have a 5. And I still have that last 7. So this one actually ends up being huge because the numbers are so big. So to find the lowest common multiplier, I would have to multiply all of those together. Okay, so if we go ahead and do that, it's going to be a huge number. So 7 2's, or to shorten it, we can go 2 to the power of 7 times 3 times 41 times 11 times 17 times 5. And we end up getting 14,720,640. So what that represents is the smallest number that all 3 of these numbers would multiply into. Okay, did that help clear up some confusion if you had any? Or if not, if you still have a question, definitely you can go ahead and ask it. Was that when you multiplied them, Monica? Did I multiply it wrong? That very well could have happened. Whoops. Times 3 times 41. Whoops. 17 times 5 times 7. Yep, I sure did multiply it wrong. Thank you. I typed it in wrong, obviously, for sure. That's terrible. So it should be 103,044,480. Okay, let me check that was your number there. Does that look right? Okay. Yes, exactly, Lincoln. So once you've used one number from whichever list, If it exists in other lists, you cross it off. So for example, with the 2 here, if I use 1, 2, I cross off 1, 2 in every other list because that was used. If I use a second 2, cross off a second 2 in every other list. If I use a third 2, cross off the third 2 in every other list. Then I had to use a 4th, 5th, 6th, and 7th 2, which didn't exist anywhere else, so I could only cross it off up here. And then I moved on to the 3. 3 only existed here, so I couldn't cross it off anywhere else. Same with 41. 11, however, exists in 2 places. So as soon as I write down 111, I cross off the 11 in the other list. Then use the 17. It doesn't exist anywhere else, so cross it off. And then the 5 and 7 as well. Oops, sorry there. Thank you. Okay, good. Yeah, I think that's where the confusion's coming from there. Michaela is just making sure you're crossing it off of every list. So if you were still having a little bit of issues with that, do maybe a couple more extra questions with LCM if you haven't done all of them, or even make some up for yourself. You can pick any numbers and find the LCM, and if you want, I can check it for you. But yes, that's where it's coming from, is you need to cross off everything. Okay, so let's jump into lesson 4. So today you're going to need your calculators for sure. And I'm still waiting on getting a calculator program from the college here. There's supposed to be something I can download on my computer. However, there was a free calculator online that I used to be able to use that no longer existed when I went to try to find it online. But I got really excited because I have downloaded this to my computer previously, so I still have this on here, so I'm actually able to pull it up for you guys. So rather than me having to just tell you, type this in, type that in, I can actually show you on here. Okay, so if you have a TI-83 or an 83 plus like this one, your calculator would look exactly like this. The 84, the buttons are all in the same spot, but there's different versions of 84, so everything's just a different color. But the buttons are all the exact same. So we do the same exact sequence of pushing things in, but on your screen with the newer versions, which are the 84s, if you have the newer programs, it might just look a little bit different on the screen, but not a big deal. So let's jump into that. Starts on page 17. And I was looking through this yesterday because sometimes I like to put my own examples and things in here. But I think it's set up pretty well in the workbook. So I'll walk you through these notes in the workbook, and then you should be good to go with determining rational and irrational numbers. Okay, so it starts off with just review, and again, it's more terminology. So math has a lot of vocabulary in it, and usually when you're thinking of a math class, you don't think of vocabulary, right? That's more like English and social studies type thing. But math and science has a ton of vocab. So we're going to talk about different types of decimals and review those first, and then we'll get into determining whether a number is rational or irrational. And those of you that are humanities, have a humanities background, rational and irrational in the English language means something different completely than in math. Okay, so we have to always have like the two definitions in our mind. So rational and irrational has to do with the type of number in math class. So the first question asks us to convert 28 over 11 to a decimal. So all you have to literally do is type in your calculator 28 divided by 11. And then equals, and we get this here. And I love that I can show this up here on the screen so I can explain why this decimal doesn't actually stop where it shows on the calculator screen with the 5. So we got 2.45, 45, 45, 45. Okay, so if the number is really long like that and has at least 2, 4, 6, 8, 9 decimal places here on the calculator, that's as many as it can fit on the screen. So it doesn't keep showing you 4 5s forever, but if you can tell that it's going all the way to the end of the screen here and there's 9 decimal spots at least, that means that's a continuing decimal. It doesn't actually stop there. The calculator just has no way of showing that to you. So that's what the ... means there. So it means it actually continues. So it says circle the correct alternatives in the following statement. So the decimal representing 25 divided by 11 has a repeating or non-repeating pattern. So that's pretty easy to figure out. When I look at my number here, and if I bring it back on the calculator as well, it goes, oops, and I wrote it down wrong. Jeez, Ashley, sorry guys. Flip that right around on you, it should be 5, 4. So it is going 2.5454545455, but you can assume it continues 4, 5, 4, 5, 4, 5, 4. So if there's obviously a pattern of numbers that are continuing to repeat, that's a repeating decimal. Now terminate and does not terminate means, so terminate means the number stops at a certain point. And then obviously does not terminate means it continues on forever or to infinity. Now, if it goes all the way to the end of the calculator screen like that, and there's a repeating pattern like that, you can assume this does not terminate, which means it goes on forever. So does not terminate or does not end. Okay, if we do 28 divided by 8, so 28 divided by 8, this definitely doesn't continue, right? There's only one decimal place there, 3.5, that's it. So there's no repeating pattern. It's literally just 3.5. There's nothing that's repeating. It's not 5, 5, 5, 5, 5 forever. It's just 3.5. So that's non-repeating and terminates because it stops after that first 5. If it was repeating, it would look like the last question. You'd have 3 point and then a bunch of 5s after it. And then you would assume, okay, that's continuing on forever. Okay, and then our last one they ask us to do is convert root 2 to a decimal. So type in square root, which is the second button, and then x squared. So for those of you that aren't familiar with your calculators, each button on here actually represents, for the most part, it can represent 3 different functions, and they're color coded. So with the 83s, the second button is yellow. So if I push the second button, and let's say number 2 down here, see those little things above the 2 on your calculator? It says L2 or Z. If I push the yellow button and then 2, I'm actually using the yellow function. So L2 comes up. If I push the green alpha button and 2, I'm going to get the letter Z. Okay? And obviously if I push nothing, I'm just going to get what's right on the button, which is 2. So lots of times you have to kind of search for those upper functions that are above the buttons, and that will tell you, okay, push the yellow button. So for example, the tan here, to get tan inverse, which we'll be using in trigonometry, you would push the yellow button and then tan, and that tan to the -1 comes up. If I want the letter G for any reason, I would push green button and then tan, and it gives me G. So with the square root, it's yellow above the x squared. So I push the yellow button and then x squared. And I'm pretty sure that for the 84s, the second button is blue. So you would have blue and green. So all that square root should be a blue color above the x squared. Okay, so just little tricks. I used this for years and didn't know that. So you might have already known that, but little things that I know I will pass along to you. And if you already know it, great. And if not, well, hey, you learned something cool. All right, square root of 2. So we get 1.414213562. So again, lots of decimal places. I've got 369 again. You can assume that decimal continues forever. Okay, so this is non-terminating or does not terminate. And if we look at the pattern of the decimal, 4142135562, there's no repeating pattern here at all. Okay, so that is non-repeating. Okay, so there is 3 different types of decimals. So there's either, like the first one, there's either repeating and non-terminating decimals, means there's a repeating pattern in there and it never ends, or you have non-repeating decimals that end. So it was like the 3.5 here. Or you can have no repeating and non-terminating decimals. And that's like 1.4142, and then it kept going there with no repeats in there whatsoever. So those are the 3 types of decimals we can have. Okay, and then just to help you remember that, there's the definitions right there. That's right out of your workbook. So repeating decimals are decimals which have a recurring pattern. So something that keeps continuing over and over. So like the 54, 54, 54, 54. Non-repeating obviously would be like this one here, where it's different numbers, where you can't see any recurring pattern in there whatsoever, or something that terminates. And then terminating decimals, they stop. In this case, it says decimals with a finite number of digits. Finite means a specific amount of digits, which is another word for saying there's a specific amount and then it ends. Non-terminating decimals, decimals with an infinite number of digits. So infinite, you can think of, infinite doesn't actually end, it goes on forever. Okay, let me stop there. Any questions so far? Two over 11. So 2 divided by 11, let's take a look at that, Jonathan. So on your screen here, Jonathan's asking, does 2 divided by 11 end? So let's do 2 divided by 11. Nope, that would be ongoing. So if you have at least 9 decimal places, so this has 3, 6, yep, this one has 10 or 11 spots, you're right. So if it has at least 9, you can assume that's ongoing, so it does not terminate. So it will keep repeating forever as 18, 18, 18, 18, 18, 18. Okay, you might have, do you have an 84 calculator? Yeah, okay, so the 84 might show you maybe one more decimal place in there. Very good question. This is where you have to get used to the calculator, so that's awesome that you brought that up. Let me show you what he's talking about. So when Jonathan, or when you try this in your calculator too, so what he's getting is 0.1818181818, and then a 2, let's say. So it looks like when you look at that, hey, wait a second, that is not that's not repeating. It looks like it's repeating, but then there's suddenly a 2 at the end. What's happening is your calculator screen, again, is only so big, but they are built to round, right? So if it has to stop at that decimal place, where really it should be this is what's actually happening. But because the calculator screen, let's say, stops here, like yours does, what it will do is it has to round this last decimal place. So because this is an 8, it rounds that up to a 2. So it makes it look like this isn't a repeating decimal. So this is just something you'll learn as you go, that you'll get used to using your calculator and doing this quite a bit. You'll just learn, okay, it rounded that last decimal place. So that's a continue. So if you see something like this where it's continuing for a lot of decimals, like 10 places, you can assume, or just do this on your paper and see, does that make sense if that was rounded? Okay, really good question. And that pops up quite a bit. Yeah, thank you for that. Okay, does anyone have questions on that? Oops, sorry. And again, it depends on your calculator version. Mine was the 83 I had up there and it didn't do that. It just happens that it had one less decimal place to show. So because it stopped after the 8 on mine, so mine stopped like this. So I just got lucky. The next number would have been a 1, right? So it wouldn't affect that. It wouldn't round that up to a 9. But it would have if this 1 is bigger than a 5, or a 5 or bigger, I should say. So you just have to be, I guess, learn to be smarter than the calculator, which sometimes I still get stuck with things. So it's just going to take practice with it. Okay, perfect. So at the bottom of that page 17, there's this question here. So all we're going to do is we're going to divide these decimals, or these fractions, to find the decimal, or we're going to look at the decimal, or find the square root to look at the decimal, and we're going to determine whether it is repeating or non-repeating, and terminating or non-terminating. So just what we were doing there, we already looked at 2 over 11. So 2 over 11, let me bring that back up there. If you have what I have here, or if you have 182 at the end, again, that's the rounding thing the calculator is doing. So 2 over 11, we'll just jump to that one first. This would be repeating, because you're getting 1, 8, 1, 8, 1, 8, 1, 8, and non-terminating, because it will go on forever. So I'm just going to put an R and NT for non-terminating. You can write out the whole word if you like. If we go back to 1/8, so the very first one, so we do 1 divided by 8. That's going to terminate, so it only has 3 decimal places. So there's the difference. A decimal that would be non-terminating will have a lot in there. One that ends will stop with like 2 or 3 or 4 or 5 decimal places. So that's 0.25. There's no repeating pattern in there, so it's just 125, and it terminates. So this is non-repeating and terminating. Okay, 9 divided by 7. Okay, here's another. Okay, this one's good. So it's 1.2857142886. So let me just write this one out. 1.28, I'll put on my calculator in front of me so I don't have to keep bringing that up. 1.2857142886. Okay, so this is definitely non-terminating, right? There's a bunch of decimal places. So we got 3, 6, 9 there. So we can say that's non-terminating, goes on forever. But is it repeating or not? So you have to be very careful with some of these decimals. So if I look at this, there's no repeat from 285714. But then we've got 286. So sometimes it helps to write this out. So if I assume, let's just assume it's repeating. I'll just leave a space in here. It's not really much of a space, is it? Let's say that's the pattern that's going to repeat, because we've got a 2 happening again and then an 8 after it. So I would have 2, 0.85714 if this repeats. Okay. Now my calculator screen again is stopping after it's doing all this and it's stopping here. So this is another case, just like the last one we talked about with the 2/11, where this is a 7, and because the calculator stops there, it has to look and see if I need to round that. So it's rounding that up to a 6. So we can assume this is actually a repeating decimal. So anytime you see a pattern of numbers and then, oh wait, a 2 is happening here again. Oh wait, there's another 8. But then instead of 5, there's a 6. It's probably a rounding thing. So if you can write that out and look at it, yes, it is. So this is actually a repeating decimal. And I think some of you guys probably figured that out. Oh, and some of you might have more decimal places. Yep. So if that happens, perfect. So 1428571. Yep. So Jonathan's had more decimal places in there, and yours might have the same thing. So it's a little bit more obvious. Okay. These ones are easier if they actually give you the decimal and you don't have to put in the calculator yourself. Whenever you have that little bar over a number, you may or may not remember this, but you have 0.9, and see how the bar is over the 4? That stands for repeating. So what that actually means is after that 9, you have just 4s repeating to infinity. So this would be a repeating pattern because that 4 is repeating. Even though the 9 doesn't show up again, that's fine. If you have some type of repetition in there, that's a repeating decimal. It's repeating and also non-terminating. Okay, now let's look at the square root of 8. So when I type that in, I get this, 2.828427,125. So it doesn't look like there's any repeating anywhere. You might have to look for a little bit just to make sure, but there's no repeating there. And also we've got at least the 9 decimal places there. We can assume it's non-terminating. So that's non-repeating and non-terminating. And then the square root of 0.16, that's our last one. So square root 0.16, 0.4. So that's definitely non-repeating, right? It's just a 0.4, and also terminating because it stops there. So that is non-repeating and terminating. Okay, so I'm glad they put those types of questions in the notes, read the tricky ones, because sometimes you'll get those tricky decimals or you have to really take a few minutes and just look at it. And some are very easy. You plug it in and it's obvious. Okay, questions on that so far? That's okay, Jonathan, no worries. So if I had 0.94 with the line on top, so would it be on top of the 4 or the 9? I guess it doesn't matter. So if, yeah, so that guy here, the one we just talked about, whether we had the line over top of just the 4, that means the 4 repeats. So even though the 9's there, because the 4 is repeating, that has a repeating pattern. So that would be repeating. And definitely if sometimes you'll get this where the bar is over top of the full 9 and 4, which means it would be 9, 4, 9, 4, 9, 4, 9, 4, 9, 4. So those are both repeating. Anytime you have that little repeat bar on top, you can assume that's a repeating decimal. Whoops, did not want to go there. Yeah, no, for sure. A couple more of what you just did, like this decimal and square roots. Yes, we're going to do, there's some examples on the next page, Lincoln, that we're going to take a look at, absolutely. Oh yeah, nope, good question, Jonathan. So as long, even if the 9's in front, just like this guy here we wrote out, whoops. If you have the 9, but you have the repeating 4 pattern, you assume that's a repeating pattern, even though the 9 is there. Okay, so we're going to talk about rational, near, and irrational, and then we'll do a bunch more examples down here. So we've got, yeah, perfect. It does use the definition I wanted to use there. Okay, so decimal numbers which repeat or terminate can be converted into fractions. So it says these numbers are called rational since they can be written as a ratio of 2 integers. So basically the way I think of rational numbers is rational numbers can always be turned into fractions. If you want a really short definition. That's not a hashtag. That's way back before we had hashtags, if you remember. You might be too young, some of you, but that's also the number sign, a really short version for talk about number. Or it could be the pound sign from a phone, but that's rational numbers can always be written as fractions. Or be turned into fractions, I'll say. So always, always. Irrational numbers can never be turned into fractions. And another way to remember it is irrational numbers are always non-repeating and non-terminating decimals. So it has to have those two things occurring at the same time. So it's not non-repeating or non-terminating. It's non-repeating and non-terminating at the same time. So irrational numbers cannot be converted or turned into fractions. Okay. So it says identify each of the following numbers as rational or irrational and give a reason in each case. Use a calculator to convert the rational numbers to improper fractions in simplest form. So this is one of my most favorite things that these TI-83s and TI-84s can do is if a decimal number is able to be turned into a fraction, the calculator will do it for you. And it will also tell you if it can't be turned into a fraction. This is one of the biggest features that I use probably the most often in this calculator is the fraction feature. Greatest thing to have. Okay, so if we look at this first number here says 1.493. So this is terminating, so it stops after the 3, and it's non-repeating. There's nothing repeating in here. So I'm just going to say this is non-repeating and terminating. So to be irrational, it has to be non-repeating and non-terminating. Well, that's not the case here. It's non-repeating, so it satisfies that, but it's terminating. So automatically that means this is a rational number. Okay, and here's our reasoning right here, because it terminates. Okay, so it wanted a reason, that's your reason. Now, to change this into a fraction, here we go. So just type the decimal in, 1.493. Okay, once you have that in, all you have to do is push the math button, which is right here. You got second in the top left, alpha below it, and math is right below that. So push the math button, and automatically what's highlighted for you is frac, and that just stands for fraction. So you literally push enter, And then what this means when this arrow comes up, it says, do you want me to turn this decimal into a fraction? You say yes, and you do that by pushing enter again. And it gives me the fraction. And it also always gives you the simplified fraction, so you don't have to worry about simplifying it yourself. So the fraction here is 1493, let's write it right here, over 1000. Okay. Now, because it is terminating, that's why it's rational. So basically, any decimal that terminates and any decimal that repeats is rational, which means they can be turned into a fraction. Any decimal that has these two things going on at the same time, always irrational, will not be able to be turned into a fraction. So for the most part, square roots that don't work out to be nice, perfect square numbers, like the root of 81 is just 9, all whole numbers are called rational numbers. So we'll get to that one in a minute, and I'll show you why and how that fraction definition can still be used for whole numbers. So if we just look at root 5 first, let's type that in. So the square root of 5 equals. So if we look at this, it's got at least 9 decimal places it's showing me, goes right to the end of the calculator screen, which means that's non-terminating. That would continue forever. And if you look at the decimals in there, there is no repetition. So there's no recurring pattern happening. It's just 236, 06, 79, 77, blah, 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 blah. There's no repeating. So that would be non-repeating and non-terminating at the same time, which is our definition of irrational. Okay, so that's irrational. Now here's the great thing about these calculators. Let's try to change this to a fraction. So once you have that answer up there, don't delete it, leave it. And if you've deleted it, just retype it in and push enter. And right after that, let's do our math. Enter on fraction, and enter again. Now the calculator, even though it stops showing you the number at 7, the calculator in its memory has the entire number logged in there. So it knows that this is non-terminating because it gave you that answer here. So it's aware of that. So it won't be able to turn it into a fraction. So when that happens, it just gives you the exact same decimal back out. And you can then assume this is irrational because I can't write it as a fraction. Okay. Now this next one, 2, 347, 347, 347, 347, dot, dot, dot. The dot, dot, dot means non-terminating. However, 347, 347, 347, 347. So it's repeating. So this is repeating and non-terminating. Okay, so that would be rational, because to be irrational, it would have to be non-repeating with non-terminating. So this is rational. And if we want to change this into a fraction, we would type in 2 point, and here's the trick with the calculator. To tell the calculator that this is a non-terminating decimal so that it goes on forever, we have to fill in the repeating numbers up to at least the end of the calculator screen. So we go 347, 347, 347, 347. You can't stop there. So that's what it gave us here on the piece of paper. If you stop there, because I didn't go all the way to the end, it tells the calculator, okay, it stops here. And then it might, even though it's a pretty long decimal, it may or may not give you a fraction. But you have to keep typing in 347, 347 until you get into at least the second row. And for the TI-84s, it'll just keep moving. It'll move the screen. So as long as you go past the end of the screen, then the calculator registers, okay, this must be a non-terminating decimal. So once we do that, then we push math, enter, enter, and there's our fraction. So if I went let's just play around with this, 347, oops, 347, 347, and I tried to change this into a fraction, it might, because it's terminating, right? If I tell the calculator, oh, this terminates, it might try to change it into a fraction for me, and sometimes it might not. So, and the reason is because this decimal place is just too long, and the fraction of this specific number that we're telling the calculator, oh, this one terminates here after this one, it's just too many decimal places and the fraction's too big that it wouldn't actually show it in here. So that's where you can go wrong with the calculator here. So if you did this question and you didn't fill it in all the way to the end of the screen and go a little bit further, the calculator assumes it stops there and it will give you the decimal back out, and you're going to think that's irrational because there's no fraction. So don't just depend on the calculator here. Also know this by heart. So you don't have to memorize the rational part, because if you can remember this for irrational, well, it has to be both non-repeating and non-terminating at the same time, and anything else is rational. So that's how I remember it. If it's not repeating and not terminating, that's irrational. Any other type of decimal is going to be automatically rational. Okay, and the calculator, like I said, can be great, but you have to know how to use it properly. And it's got these little glitches in it, so I'm going to try to teach you those as we go. It's going to take you a little bit to get used to. Okay. Any questions on that? Oh, thanks, Bo. You have a good day. Syntax error. Okay, let's try that. So let's try root 5. Oh, we already did root 5. Let's see what happened here with yours. So square root of 5. This is part B here. I wonder why you got syntax error. Try it again, Jonathan, and see. Okay, in the meantime, let's try negative root 81. I'll come check that in a second, Jonathan. So negative root 81, we can just do this one on our heads. You can plug it in the calculator too, but would be equal to negative, and the square root of 81 is 9. Okay, so I was saying earlier that any whole number, positive or negative, is always rational. And the reason is because I can write any whole number, whether it's positive or whatever it's negative, I can write it as a fraction. You don't need your calculator for this, and the calculator won't actually do it for you because it's not simplified, but any whole number you can write as a denominator of 1, right? Because fraction just means division. So if I do negative 9 divided by 1, it's negative 9. So you can automatically assume any whole number, positive number or negative number, is always rational. And you can also remember that by knowing, okay, negative 9 is not a non-repeating or non-terminating decimal, so it can't be irrational, therefore it has to be rational. Okay, and if we try in the calculator, let's just do this for fun. Let's try to do negative 9 and then go math, enter, enter for fraction. Yeah, see, it won't give it to you because it always gives you the simplified answer. And negative 9 over 1 is obviously not simplified, right? You'd actually do the division. Negative 9 divided by 1 is negative 9. Still not working? Okay, I can talk to you about that later, Jonathan. You might have to just try to reset your calculator, and I can show you how to do that. Sometimes calculators mess up, and if you reset them, it kind of just like resetting your phone. I'll show you how to do that at the end here. So if we look at E, the square root of 4.41, so let's type that in, equals 2.1. So that is non-repeating and terminating. So again, to be irrational, it has to be both non-repeating and non-terminating. This only has half of that, so this would have to be rational. And if we change that into a fraction, all you have to do is have your answer up there, math button, enter, enter. 21 over 10. Okay, now F is a really good question. We've got negative 8.1122111222111. So it's, the decimal is 2 1s, 2 2s, 3 1s, 2 2s, 4 1s. And you can imagine what would be next would be 4 2s, 5 1s, 5 2s, 6 1s, 6 2s. So because of the dot, 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 we definitely know it's non-terminating. But is it repeating or non-repeating? And you have to think about that really hard. So to be repeating, it has to repeat the exact same pattern over and over and over again. So even though it seems to have it has a bit of a pattern to it, it's not a recurring pattern. It's not the exact same thing over and over again. So for it to be repeating, it would have to be 0.1122, 1122, 1122, 1122. So this is actually non-repeating. So non-repeating and non-terminating. So that is the definition of irrational. Okay, and with the calculator, we can plug that in. So we can go negative 8.1122, 3 1s, 3 2s, 4 1s, 4 2s. And you can even stop after the 1s because that took me to the end of the screen and a little bit further. So always go a little bit further than the end of the screen. Math, enter, enter. Doesn't work. So that means irrational. Okay. Any questions, anyone? And I'll show you how to reset your calculator because sometimes if things mix up on there, and we get into graphing too, sometimes the calculators glitch out a little bit and we just have to reset them. Okay, perfect. This next question's fairly simple. So all we're doing is we're going to order the following rational numbers on a number line. So root 14, you might have an idea of what that might equal just by thinking about the closest perfect square. So we can think about it this way. The closest perfect square that's smaller than 14 would be root 9. And then the one that's bigger would be root 16. Right, so this root 14 falls right in between these two. And because we know root 9 is 3 and we know root 16 is 4, it's going to be 3 point something because it's in between those two numbers. And because 14 is closer to 16 than it is to 9, it's probably going to be 3.7 or something like that. Okay, but if we type it in, that's just how you would estimate if you didn't have a calculator. So if we type in the square root of 14, yeah, good guess. So it was 3.7, I actually guessed that. Usually I never get those right. 3.741657387. So that is non-terminating. It has at least 9 decimal places right to the end of the screen. And there's no repetition in there. So that's non-repeating, non-terminating. And on our number line here, 3.7 would be about there. So there's root 14. Pi, you guys should all know, pi is probably the most famous irrational number. So to get the pi button, on your calculator, right above this the division sign here, there's this little upwards arrow, it's actually called a caret. That's your exponent button. But above that, in yellow, is pi. So you hit your yellow button, or in the IE4s, it'll be blue. And then that caret button, it gives you pi. And then push enter, and there's pi. And we all know that pi continues on to infinity. It goes forever. And you can tell that in the calculator again because it has at least 9 decimal places, so it continues. And pi has no repeating pattern. So pi is irrational. And on our number line, 3.14-ish is about here. Okay, root 80. .9-ish, so we're going to go right before 9. That'll be root 80. 2 root 15. So how we would plug that in the calculator is exactly how it's written. What this actually means is 2 times the square root of 15, but we don't have to put the multiplication button in there. If you put just 2 root 15, the calculator knows that means multiply. But if you want to use the times sign, you can. You can go 2 times and then the square root of 15, but I'm just going to do what it says on the paper. And we get 7.7455 or 4966692. Now, just because those 3 6s repeat right there, if you look after that, you got 92. That's not repeating. So 7.745-ish would be right about here. So there's 2 root 15. And then the square root of 0.1. .316227766. So again, that's non-repeating and non-terminating, so that should be irrational. If you want to double check, because it looks like there's some repetition there, even though we know by looking at it, it's not exact repetition, it's not a recurring pattern. But if I do math, enter, it gives me the same decimal. It means, yes, it is irrational. So it's non-repeating, non-terminating. And 0.3 would be about here. Okay, so the only number we might have known, obviously by heart, would be the pi. You know it's 3.14, but that's just the first little piece of it. It's 3.14159. It continues. That would be probably the only one that you could guess just by looking at. So we're going to move more into radicals next week, and we'll do some more work with these and how we can manipulate them without using a calculator to kind of know more, so which number would be bigger, which one would be smaller. Okay, so right now just using your calculator. And then the last piece we want to look at today is the example 4 here. It gives us the calculator screen, which is nice, but I'll do it on the screen as well. It says using a graphing calculator, or use a graphing calculator to convert each of the following to an improper fraction in simplest form. So it did this one for us, but just like I was saying, if it's a repeating decimal, I can't just type in 0.36. Right? That doesn't tell the calculator this is repeating. This tells the calculator that terminates and doesn't repeat because I typed in 0.36. So if I go math, enter, I'm not going to get the correct answer, which should be 4/11, because I gave it a different number than what it actually is. So to do this correctly, if it's repeating, like I was saying earlier, you have to do the repeated pattern. You have to carry it all the way to the end of the screen and go a little bit past Okay, and then go math, enter, enter. And that gives me the correct decimal, or the correct fraction, sorry. Okay, and then part B for 3.95, so we go 3.9, and the repeating part is 5. You just have to carry 5 all the way to the end and go a little bit further. So we'll get 178. Oops, sorry. Eraser. Should be 178 over 45. All right, let me just leave that scribble there for now. There we go. Okay, so definitely today, the main point is practicing with that calculator. So definitely do those questions. In your workbook, there's page 19 that shows you how to change these types of fractions into, or these types of decimals into fractions by hand without using the calculator. And that's on page 19. So what I'm going to let you know, oh my gosh, this is, sorry everyone, a little frustrating. We're right at the end of class too, so I don't want to keep you too long. Okay, look, page 19 is optional. If you would like to know how to convert these fractions or these decimals into fractions by hand, by all means go through that. I'm not going to go through it with you. It's a pretty complex process. Something that you won't have to use in 20 or 30. The only time it will pop up again is if you're going to take calculus. And if you're going to take calculus, it'll be a pretty quick thing for you to learn, so you can just wait and do it then. Or if you're really interested and you have time and you want to know how, go ahead and work through page 19. Otherwise, just avoid it. And any questions in the assignment where it says to do it by hand, just ignore that and use your calculator. And I think in your checklist as well, in your weekly guide, it tells you to go through the by hand stuff. Again, just ignore that. You won't have any test questions that makes you do that. You can use your calculator for all of it. Okay. All right, sorry I went a minute or so over time. I know some of you guys have a really tight schedule. I just stopped using my screen here. Let me turn on my camera. There we go. Okay. So for tomorrow, you're going to have that a self-assessment numbers quiz. And again, I'll put a news item in our D2L shell, so you'll be able to just click on it and go to the quiz right from there. You'll have 90 minutes to do it. Probably won't take you that long though, but just give yourself that much time just in case at some point tomorrow, and then you just submit that and you'll be good to go. Otherwise, you're just working on the assignment questions, and if you're a little bit behind, just getting caught up and watching some of those videos. Okay, I will see you tomorrow at 2 o'clock. So if you have any questions and you want to leave the quiz until after tomorrow's class, you can definitely do that as well. Or you can do it tomorrow morning, whatever works for best for your schedule.
Okay, I have a question. This is Miss Sarah.
Yeah, go for it, Seda.
And the test date is covered until lesson 1 or lesson